Here we're taking a look back at sigma notation here, and we're going to use that to complete some of the information. So sigma notation, if you remember, we have this equation or expression here, 4i cubed minus 1. And what sigma notation means is we're going to plug in this number first, and then we're going to plug in every number after that, every whole number after that, up until this number at the top. So I'm going to write out the actual, like, what the equation looks like first. Then I'll kind of plug it all into a calculator and get my actual value because it asks me to expand and evaluate. So the first thing I plug in is 3. And then I'm going to add the next value together, where it is me plugging in the next value up, which is 4. Then I'm going to add the next value, which is 5. Then I'm going to add the next one, which is 6. And that's like all the math that needs to be done, right? Because I'm taking this equation and I am adding each of these values after plugging in 3, then 4, then 5, then 6. And so when I plug this into a calculator, again, I could just plug it in that whole string, or I could find each of these 4 different terms that we get and add those together. But either way, we should end up getting 1,724 for the value of this expression using sigma notation. Write the following expression in sigma notation at the bottom here. So a couple things to do for this one. Basically, when I am going through this, I am going to start by writing sigma notation. I always like to start, I use k, but the variable doesn't necessarily matter. But I always want to start at 0 personally, because then what I can see what's happening here, I can kind of create a linear equation with like y equals mx plus b type of a thing. And so, first of all, this 0.4 here is happening on the outside of like all this stuff that's being added. So in this case here, I could either put the 0.4 in the front here and then multiply it by the sigma notation, or I could have it on the inside. It doesn't necessarily matter. So I'll leave it out in the front just to show you a different look. But the actual sigma notation here, I can see that I have fractions, and the only thing that's changing in the fraction is the denominator. So that's what's going to have my variable here of k. So I'm going to have 1 over. I see that it is going up, or the denominator is going up by 0.4 each time. So I would say 0.4k, because that's like my rate of change. And then the first value here that my denominator is at is 2. And so again, like I'm saying, it's kind of like our like mx plus b situation here, where I know the rate of change is 0.4, the starting value is 2, and then I'm using the variable k here. And so the last thing that I need to do is plug in the last number that I would, plug in to get this value here, 1 over 3.6. So if this value here, if I plug in 0, I get 1/2, right? Literally just look at it. If I plugged 0 in for k, I get 0 plus 2 on the bottom, so I would get 1/2. When I plug in 1, I should get this value right here, which is true. When I plug in 2, I should get this value here. When I plug in 3, I should get this value here. When I plug in 4, that's the final value that I plug in. So that's going to be that top number on sigma notation. So in this case here, my sigma notation is 0.4 times k equals 0, sigma notation, 4 on the top, and then my actual equation here in parentheses.